Okay, apologies for those who couldn't make the lesson today. My recording is starting now. I have just been through a recap example and the first two questions of Mr. Stratford's notes. I apologize if you missed these. If you need me to make another video, let me know. Okay. However, I'm just going to carry on. I'm not going to repeat it for those who've been listening the whole time. Okay, now we get on to the tricky stuff, the really tricky stuff, which is integration by substitution, where you are not given the substitution. Now, if this is the case, bad news, essentially. Okay. Now, sometimes the substitution will be quite obvious. And I think the two questions in these examples here, it does sort of make sense. However, sometimes they can be really, really tricky. Now, I think what we might try and do is produce a list of common types of questions and the common types of substitutions you might have to do. Now, it'll make a bit of sense, I think, for the two that I'm going to be doing here. However, it may not make sense on certain examples. I think maybe when it's logs or exponentials, it's particularly tricky, and we don't have any like that yet, but we'll have a think of them in the future. So it says, up until now, we've been given the substitution, which is like 90% of the time, I think they'll give you that in the exam. Sometimes we may have to find our own substitution. So it says then a very important point here. You should probably have noticed that when we've completed the substitution up until this point, all x values have cancelled out. Now that is what we are aiming to do. When we choose a substitution, that's what we want. We want our x values to cancel, because then we'll just be left with things in terms of u. Now remember, when it cancels out when I replace it with u equals whatever the substitution is. Well, that doesn't matter because I'm just going to be putting in a u there instead of the letter x. So there's not going to be any x's left. But it also cancels out when I put dx equals something. This is the important part. Okay. Now, when I differentiate, I'm looking to pick something to substitute in, but when I differentiate it and rearrange it to get dx, then something cancels out. Now, that may be quite a difficult concept to understand, but let's have a look at this question here. Use a suitable substitution to evaluate this here, x squared minus 2x. Now, let's focus on this top line. This top line, as you've probably noticed with a lot of these, I end up, because I rearrange with dx equals something, it usually ends up being a fraction, something over something. And the x terms are usually on the bottom of this fraction, and it's usually du on the top. So I'm looking to cancel this top line here of x squared minus 2x with something on the bottom. So if I choose this bit underneath the integral here, x cubed minus 3x squared, then if I was then to differentiate this, I end up with 3x squared minus 6x, which has some sort of relationship with this thing on the top. You know, so they both have an x squared and an x term. And hopefully you can notice that if I was to factorize this, it would actually be 3 brackets x squared minus 2x, which is the same thing that's on the top there. Now, hopefully, if we have one where you have to choose your own substitution, it'll be a common question like this. Now, of course, I then need to rearrange this to get dx equals du over 3x squared minus 6x. Now, remember what I was saying? If I have something on the top, I want that to cancel out with something on the bottom. Now, this something on the bottom is now 3x squared minus 6x, which will be factorized to cancel out with this here. So if I scroll down here, those are the steps that they've taken. They chose their substitution to be this here, then they differentiated as I did, then they rearranged to get this. And if you substitute all of those things back in to this original equation here, The bottom, well, this was what u was. That gets replaced with u. That's not a concern. That's just involving the letter u. It's the thing that involves the x's that is the concern. So if you have du over 3x squared minus 6x to sub in instead of dx, then that goes on the end there. And we're looking for this part here to somehow cancel out the x's with this part here. That's what we're aiming to do. So we're trying to choose a substitution that when we differentiate it, it ends up cancelling something out. Now, as Mr. Stratford has done here, he has factorized the bottom, and we end up having this on the top and that on the bottom. And those two things will cancel out. Therefore, there's no x's left. So our steps to choosing something, we choose something that when you differentiate it, it may cancel out with something that is on the top. Now, if there is a square root or something like that in our question, the trick tends to mostly be that we choose our substitution of u equals whatever is underneath the square root. Sometimes if there's a bracket involved, it can be one of the brackets that we choose as our substitution. And you've probably noticed that in some of my questions so far. It tends to be something that's already there, something in a bracket, or underneath a root. From this point on in the question, it's the same as always. Okay, you end up with a third u to the minus half. Then you can take that out, and you end up with this. And your final answer is this, apart from subbing in u again, where we get that. So obviously the far trickier element of this is choosing your substitution wisely. Now you'll notice if you've done your substitution wrong, I guess, because nothing will cancel out or not enough will cancel out. You'll be left with an x term still in there. The aim is to have only u. We don't want x's. Okay, so next question. There's only one more to go today. This one here, okay, I think, I had a quick check this, I think Mr. Stratford's accidentally written that twice there. Okay, so that's the question. So it's x minus, well, the integral of x minus 1 times sine of all of this. Now, there's an important point. I don't want to reveal the answer just yet. But there's an important point that Mr. Stratford's right here. It says, don't get put off by the sign. We're still looking for something that when we differentiate it, remember it usually goes to the bottom of this, something that when we differentiate it on the bottom here will cancel out with something on the top. Now the fact that this is a sine term hopefully should not matter, because remember we're trying to create u equals something. And if I replace this bracket with u, then I'll end up with sine u eventually. Okay, sine u. So it won't matter there. Nothing will need to cancel out, hopefully, with this term. Now let's just try something. The common thing is that it tends to be one of the brackets or something. So if I choose the bracket that comes after sine and differentiate that, I end up with 2x minus 2. Now, does that have a connection with this bracket here? Because that's the thing that we'll probably have to cancel out. If this is going to be replaced by u, it won't matter for the sine term. It's this thing that we'll have to cancel out. Well, hopefully you can notice that that factorizes to 2 brackets x minus 1, where I have a bracket of x minus 1 and a bracket of x minus 1. And they're going to cancel out, because what I'm going to do is I'm going to rearrange this to get dx equals du over 2 brackets x minus 1. And that's what's going to be substituted in, along with u for this part here. So here are my steps later on, a little bit neater than what I was saying. Okay, again, I think he's perhaps written that twice there. Okay, so u is this, du by dx is this, dx is that. Remember, the substitution and the dx are the two things that I am substituting in. So if I substitute them in, then u replaces this bracket and dx replaces that there. And I end up with this here. Okay, so remember, u replaces the bracket, so it becomes sine u. Dx is replaced with what it was rearranged as, which was du over this, or the factorized version that I had there. There I have a x minus 1 on the bottom and an x minus 1 on the top. And I am just left with, well, it's a half because there's a 2 on the bottom, which I can take outside. And sine u is the only thing that's left. Integrating sine u is minus cos u. So there's a plus c missing there. And we end up with this once I substitute u back in. Now, those two questions are particularly complicated. Again, I would recommend watching this back, pausing it if you need to, and having a go yourself. We're obviously very much available over the next day or so to answer questions. You'll have a task to do tomorrow afternoon. These questions are difficult. If you have one, you have to choose a substitution. Most of the time, the substitution is just a bracket or something like that that's already there within the question. Next week, we might have a think about something else and a really, really difficult one. But choosing the substitution is not always necessarily obvious, but you're trying to choose something that when you differentiate it, it'll cancel out probably with something that's on the top. Okay, all right, unless you have any questions, that's all from me today.